When filling out panel schedules and dealing with Plugmold, it's important to make several key assumptions to accurately calculate the electrical load. Firstly, the volt-amps per foot of Plugmold needs to be known. This crucial information is typically available in the manufacturer's specifications for the specific Plugmold being used. Secondly, the length of the Plugmold run must be determined. This information can usually be found in the project plans, which will specify the total length of the Plugmold installation. Thirdly, the number of outlets or receptacles present in the Plugmold section should be identified. This information is also generally found in the project plans, indicating how many outlets are integrated into the Plugmold system. Fourthly, the load per outlet must be known or assumed. This value represents the typical or maximum electrical demand expected from each individual outlet on the Plugmold. It is often provided in the manufacturer's specifications for the outlets themselves. Fifthly, the diversity factor for the outlet should be determined. The diversity factor is a crucial element in calculating the overall load, accounting for the fact that not all outlets will be operating at their maximum load simultaneously. This factor can often be found in the National Electrical Code, NEC, or potentially in the manufacturer's specifications for the outlets, providing guidance on how to adjust the total load calculation based on typical usage patterns. Once all of these pieces of information are gathered, calculating the total volt-amps, or for the Plugmold run, is a straightforward process. You simply multiply the volt-amps per foot by the total length of the Plugmold. This calculation provides the total volt-ampere rating for the entire Plugmold section. Next, to determine the total load for the Plugmold, you multiply the total volt-amps by the diversity factor. This adjustment accounts for the non-simultaneous use of all outlets, providing a more realistic estimate of the actual load that the Plugmold will place on the electrical panel. It is correct to approach Plugmold calculations in a similar manner to track lighting calculations. Both involve determining the volt-amps per foot and the length of the run to calculate the total volt-amps. This approach provides a standardized method for estimating the electrical load of these types of systems. Let's consider a Plugmold example to illustrate this process. Assume the Plugmold has a rating of 5 volt-amps per foot and a total length of 100 feet. Also, let's assume there are 20 outlets on the Plugmold, and the load per outlet is 1.5 amps with a diversity factor of 0.75. To calculate the total volt-amps, you multiply the volt-amps per foot, which is 5, by the length of the Plugmold, which is 100 feet, resulting in 500 volt-amps. To calculate the total load, you multiply the total volt-amps, which is 500, by the diversity factor, which is 0.75, resulting in 375 volt-amps. Now let's look at a track lighting example. Suppose the track lighting is rated at 10 volt-amps per foot, and the length of the track lighting run is 50 feet. There are 10 outlets on the track lighting, each with a load of 2 amps, and the diversity factor is 0.65. To calculate the total volt-amps, you multiply the volt-amps per foot, which is 10, by the length of the track lighting, which is 50 feet, resulting in 500 volt-amps. To calculate the total load, you multiply the total volt-amps, which is 500, by the diversity factor, which is 0.65, resulting in 325 volt-amps. When dealing with Plugmold in panel schedules, understanding the assumptions and calculations is crucial for accurate electrical planning and safety. This includes knowing the volt-amps per foot, the length of the Plugmold, the number of outlets, the load per outlet, and the diversity factor. These elements collectively contribute to a reliable assessment of the electrical demand. The volt-amps per foot rating is typically a manufacturer-specified value, indicating the electrical capacity of the Plugmold per unit length. It's an essential parameter for estimating the overall load. The length of the Plugmold, usually available in the project plans, determines the total extent of the installation and directly impacts the total volt-amp calculation. The number of outlets on the Plugmold reflects the quantity of connection points available for electrical devices, contributing to the overall load demand. The load per outlet represents the anticipated or maximum electrical draw from each individual outlet, typically found in the manufacturer's specifications. The diversity factor accounts for the realistic, non-simultaneous use of all outlets, providing a more accurate estimation of the total load in the electrical system. NEC tables and manufacturer data offer guidance on appropriate diversity factors. Calculating the total volt amps involves multiplying the volt amps per foot by the total length of the plug mold. This yields the aggregate volt amp rating for the entire plug mold system. Determining the total load requires multiplying the total volt amps by the diversity factor. This adjustment accounts for the fact that not all outlets will be operating at their maximum load concurrently. In practical applications, Plugmold is often used in various settings, such as workshops, laboratories, and retail spaces. Each environment may have different load characteristics and diversity factors. Workshops may have power tools and equipment with intermittent usage requiring a diversity factor that reflects this pattern. Laboratories often have sensitive equipment and varying power demands, necessitating a careful assessment of the diversity factor. Retail spaces may have lighting, displays, and point-of-sale systems, each with its own load profile and contribution to the overall diversity factor. The NEC provides guidance on diversity factors for various types of occupancies and electrical systems. NEC Table 220.12, for example, provides general lighting load requirements based on occupancy type. NEC Article 220 covers branch circuit, feeder, and service calculations. NEC Section 220.42 addresses general lighting loads. In addition to the NEC, manufacturers of plug mold and electrical outlets often provide specific data and recommendations related to load calculations and diversity factors. This information can be valuable for ensuring accurate and safe electrical installations. Consulting with qualified electrical engineers and contractors is crucial for complex projects or when uncertainties arise. They can provide expert guidance on selecting appropriate diversity factors and performing accurate load calculations. Failure to account for diversity factors or inaccurately estimating loads can lead to overloaded circuits, trip breakers, and potential safety hazards. Therefore, careful attention to detail and adherence to industry best practices are essential. Remember to always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements. This information is critical for ensuring compliance and safety in all electrical installations. Furthermore, regular inspections and maintenance of electrical systems can help identify potential problems and prevent future issues. Consider the example of a workshop with a 20-foot section of plug mold rated at 5 volt amps per foot. The workshop has several power tools with varying load demands. Firstly, calculate the total volt amps by multiplying 5 volt amps per foot by 20 feet, resulting in 100 volt amps. Secondly, determine the diversity factor based on the anticipated usage patterns of the power tools. A diversity factor of 0.6 may be appropriate if not all tools are expected to be used simultaneously. Thirdly, calculate the total load by multiplying the total volt amps of 100 by the diversity factor of 0.6, resulting in 60 volt amps. Now, consider a laboratory with a 30-foot section of plug mold rated at 5 volt amps per foot. The laboratory has sensitive equipment with varying power requirements. Firstly, calculate the total volt amps by multiplying 5 volt amps per foot by 30 feet, resulting in 150 volt amps. Secondly, determine the diversity factor based on the anticipated usage patterns of the equipment. A diversity factor of 0.8 may be appropriate due to the critical nature of the equipment. Thirdly, calculate the total load by multiplying the total volt amps of 150 by the diversity factor of 0.8, resulting in 120 volt amps. Finally, consider a retail space with a 40-foot section of plug mold rated at 5 volt amps per foot. The retail space has lighting, displays, and point-of-sale systems. Firstly, calculate the total volt amps by multiplying 5 volt amps per foot by 40 feet, resulting in 200 volt amps. Secondly, determine the diversity factor based on the anticipated usage patterns of the various loads. A diversity factor of 0.7 may be appropriate due to the mix of lighting, displays, and point-of-sale systems. Thirdly, calculate the total load by multiplying the total voltamps of 200 by the diversity factor of 0.7, resulting in 140 volt amps. These examples illustrate the importance of considering the specific application and load characteristics when determining diversity factors for Plugmold installations. Consulting with qualified professionals and referring to the NEC and manufacturer data is crucial for accurate and safe electrical planning. It is also essential to consider future expansion or changes in load requirements when designing electrical systems. Overestimating the load can provide a margin of safety and accommodate future needs. However, excessive overestimation can lead to unnecessary costs and inefficient system design. Therefore, a balanced approach is essential. Remember that electrical codes and standards are constantly evolving, so staying informed and up to date is crucial for electrical professionals. Continuing education and professional development can help ensure compliance and safety in all electrical work. In addition to the calculations and assumptions discussed, it's important to consider the physical installation of the Plugmold. Proper wiring practices, grounding, and overcurrent protection are essential for safe and reliable operation. Using appropriate wire sizes, connectors, and grounding techniques can minimize the risk of electrical hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overload and short-circuit conditions. Selecting the correct size and type of overcurrent protection device is crucial for preventing damage to equipment and ensuring safety. Regular testing and inspection of electrical systems can help identify potential problems before they become serious hazards. Infrared thermography, for example, can be used to detect hotspots in electrical connections, indicating loose connections or overloaded circuits. By addressing these issues proactively, electrical professionals can maintain safe and reliable electrical systems. Plugmold is a versatile and convenient electrical wiring solution that can be used in a variety of applications. Understanding the assumptions and calculations involved in panel schedules is crucial for accurate electrical planning and safety. Consulting with qualified professionals and adhering to industry best practices can help ensure that Plugmold installations are safe, reliable, and compliant with electrical codes and standards. Considering the long-term performance and maintenance of electrical systems is also essential. Regular inspections, testing, and preventive maintenance can help extend the lifespan of electrical equipment and minimize the risk of failures. Documenting electrical system designs, calculations, and maintenance records is also important for future reference and troubleshooting. Having accurate and up-to-date documentation can save time and effort when diagnosing problems or making modifications to the electrical system. By adopting a comprehensive approach to electrical planning, installation, and maintenance, electrical professionals can ensure safe, reliable, and efficient electrical systems for their clients. This includes staying informed about new technologies, best practices, and regulatory changes. The electrical industry is constantly evolving, so continuous learning and professional development are essential for success. In summary, accurately calculating Plugmold loads for panel schedules requires a clear understanding of several key factors. These include the voltamps per foot rating, the length of the Plugmold run, the number of outlets, the load per outlet, and the appropriate diversity factor. Firstly, consult the manufacturer's specifications for the specific Plugmold being used to determine the voltamps per foot rating. This is a crucial parameter that directly impacts the total load calculation. Secondly, obtain the length of the Plugmold run from the project plans. This information is essential for calculating the total volt amps for the entire section of Plugmold. Thirdly, identify the number of outlets in the Plugmold section from the project plans. This will help determine the overall load demand and influence the selection of an appropriate diversity factor. Fourthly, determine the load per outlet typically available in the manufacturer's specifications for the outlets themselves. This value represents the maximum electrical draw expected from each individual outlet. Fifthly, select an appropriate diversity factor based on the anticipated usage patterns of the outlets. Consult the NEC or manufacturer's data for guidance on selecting a suitable diversity factor for the specific application. Once these parameters are established, calculate the total voltamps by multiplying the voltamps per foot by the length of the plug mold. This will provide the total electrical capacity of the plug mold section. Finally, calculate the total load by multiplying the total voltamps by the diversity factor. This adjustment accounts for the realistic, non-simultaneous use of all outlets and provides a more accurate estimate of the actual load on the electrical system.